Alright, we're going to take a quick look at how to graph a quadratic equation. Up here I have the quadratic equation written, y equals 2x squared plus 4x minus 4. And the first thing we want to do is identify three important numbers in this equation. The first one being our leading coefficient, that being the coefficient of the x squared term, and that's 2. The next one is of the x to the first term, and that's 4. And the last one is this 0 degree term on the end, that's negative 4. Those three values are going to help us a lot in graphing this function. First things first, we have to identify a line of symmetry. Quadratic equations have the shape of a parabola, and a parabola has something called a line of symmetry. You may have studied that in geometry class, but it pops up again here in algebra. So in order to do that, we use the formula of x equals the opposite of b over 2a. And that will give us the equation of the line of symmetry. So we're going to pull the b term from up here and the a term from up here. So now we have x equals the opposite of 4 over 2 times 2. So now I have x equals negative 1 for my line of symmetry. So I'll go over to my graph, and I'm going to graph the line x equals 1. Sorry, negative 1. There's the line x equals negative 1. That is my line of symmetry, or the axis of symmetry. Now I'm going to find the vertex of our parabola, which lies on our line of symmetry. Knowing that it lies on the line of symmetry, I know the x value will be negative 1. To find the corresponding y value, I'm going to take that negative 1 and put it into my equation. So we have y equals 2 times negative 1 squared plus 4 times negative 1 minus 4. Do a little simplification there. This gives me 2 minus 4 minus 4. So the y value equals negative 6. So the vertex is at negative 1, negative 6. So I'm going to take and put that on my graph. Negative 1 is my line of symmetry, and I go down to negative 6. And that will be my vertex. Okay, great. Next off, I want to find where it crosses the y-axis, otherwise known as the Y-intercept. Now, one of the things we know about all the points on the y-axis is that the x value at any one of these points is 0. So what I would do is I'd go back to my original equation and I put in 0 for all my x values. Basically, what that causes to happen is this term will become a 0, this term becomes a 0, and I'm left with this last term of negative 4. A shortcut method one quickly recognizes is that the y-intercept will be at 0, c. Or in this case, that means it's at 0, negative 4. So I'll go over to my graph and I'll plot that point. 0, negative 4. Now I also like to find one more point on that same side of the line of symmetry. So let's put in the x value of 1. So I'll go back to my original equation and I'm going to put in an x value of 1. So now I get y equals 2 times 1 squared plus 4 times 1 minus 4. So I've got y equals, this becomes 2 plus 4 is 6, minus 4 is 2. So I have the point now 1, 2 that I can plot. 1, 2. I've got half of my parabola here now, so I want to get the other half. Now because I have my line of symmetry, I can just go ahead and reflect each of these points over that line of symmetry. So this was the point 0, negative 4. That's 1 unit to the right of my line of symmetry, so I'll go 1 unit to the left, and now I get the point negative 2, negative 4. And I'm going to do the same thing up here at my point that was at 1, 2. That's 2 units to the right of my line of symmetry. I'll go 2 units to the left, and that puts me right here. That's the value of 3, 2. Actually, negative 3, 2. And I can use those points to sketch in my parabola. And there we have it. We have a parabola graphed from the standard form of a quadratic equation. Hope that helps.